Yeah, so today for the YPPDO, we have Chris Davis presenting real physics to used cars transitioning to a data science career. So as you might guess from the title, Chris is a Yale Wright Lab alum. He defended his PhD thesis in fall 2019, working on the Corey experiment under Reina Maruyama. He did harder work on the Corey calibration system and performed an analysis for Myron protocols with Corey data. After that, he worked as an Insight data science fellow and then started working at CarMax in 2020, which will be what this talk will be about. Welcome, Chris.
Thank you. Very good to be back. Spent many hours in these offices in the seminar room, so it's very fun to be giving another seminar here. Let's see if I can actually do the talk. Cool. So I'll talk about a few things here. First, I want to go to talk about what is data science. For those of you who have maybe no experience what it actually is, talk about what do I actually do as a data scientist, generally speaking, data scientist, and also for myself, what my work looks like. Then I'll kind of transition more towards what I think y'all might want to hear more about. Let's kind of talk about what my path has been towards data science, where I went from graduate school through data science boot camp to actually becoming a data scientist. Talk about some helpful mentorship that I had, people that I really just followed in their footsteps to do this more than like, don't think of me as a trailblazer. There's other folks that were doing the hard trailblazing work for me that I said, great, that looks good, I'll do that too. Then additionally, I'll talk a little bit at the end, more on the like personal, emotional side of making transitions. Some of it will still be true for staying inside academia, but I'll be focusing more on what it's like to transition outside of academia to do a career change, more than just advancing in your current career. Talk about what you might be feeling as you go through it, things that I certainly felt myself, and give what I think are healthy coping mechanisms to go manage that. So I've definitely seen folks who have done unhealthy things, I've done unhealthy things, so be focusing more on what you can do to manage that best. So first off, I want to talk about a little bit is what is data science? So I think the best way to think about what data science is think about what things you use in daily life that are data science. So y'all don't need like raise your hands or anything, but like nod your head along if these things are like things you've seen before. So hopefully y'all have all used things like ChatGPT or GitHub Copilot, kind of large language models. I wrote part of this presentation using ChatGPT, so I'll be honest for that. It's really great to help you do writing. I wrote the whole abstract almost entirely using ChatGPT as well for the talk. I just said, hey, here's some stuff about me, write me an abstract, wrote an abstract. I edited it a little bit more, said, hey, here's my abstract, make it better. And then I use that. So full disclosure for that. It's a really great, cool data science thing. You also have like all of Facebook and Instagram. They have a lot of image recognition, which I usually think of for them. But more of the stuff they do later, but thinking about like you see a photo online, it'll say this photo may contain you and two dogs and things like that. They're able to look at an image, determine what is in that image, what is it like. Instagram's also really big for that. I made a fun little data science project using Instagram, looking at like hairstyles and hair colors. So I did that, and like Yelp data was my big like insight project, was very fun. Those of you who use TikTok, it's my main way I spend my time outside of work or inside work even sometimes. It's built around how do you get engagement, how do you find content that will be engaging to users, how do you provide them that content. You have things like Netflix and Spotify, which do also recommendation algorithms, but they're really big at Netflix for not just using it for recommendation, but using it for knowing which shows to keep or cancel. When your shows that you like get canceled very quickly, you should blame Netflix's data scientists as part of that process of like, what are they looking at? Are they telling to see people who are watching these shows who fit into certain groups? Are they subscribing? Are they staying unsubscribed after they watch shows? Do they only watch shows part way? That is data science analytics you can do for that. Spotify, you look at your playlist you get every week. Those are recommendation algorithms from AI saying, if you like these type of music here, people who are like you also like other types of music like here. These fit in that bucket, let's give them to you. You have things like targeted advertising, things that are, you go online on Google, it has a profile for each person, things that you're looking at this thing, it will say, oh, people look at this, also we're more likely to click on ads that are of this type. They will try and target advertising towards you. This is a huge way people make lots of money. It is why Google is so rich, is because they can tell data about you and give you ads that you're slightly more likely to click and buy something through, and that is worth an insane amount of money. So it's a huge data science use case. Also fun things are AI generated art is pretty cool. Things like Dolly and others. I use it in my tabletop gaming quite a bit for D&D. You want to make something fun and weird, you make a character, you can use an AI art to go do that. It's pretty fun. And then lastly, I think about pricing, which is what I do. I think of like airplane tickets might be the most thing that y'all may engage with as you're doing flights for conferences. That's going to be done through AI. And quickly for me, car pricing is done entirely through AI. So it's a computer that says, this car should have this price on it. We should buy your car for this price. We should sell your car for this price. That is all done by a computer. There's some human element, but it's very, very small. It's almost entirely computer. So those are things you should think of when I'm describing data science, things that exist like this as products. But I'll say, going back to data science, like what is it? Like try and pin down someone for definition of data science is really difficult. You ask 10 people, you're gonna get 10 definitions. So I'm gonna add an 11th definition on top of that. I really think data science is really built around decision-making. You can make predictions. You can do a lot of things that would call data science to that, but I think what really makes something data science is that you're using predictions to make decisions. So I define it as having a computer use an algorithm to determine key parameters. The way I think of this to translate that to a physics brain, to a physics analogy, is every time you are fitting your data, you have some curve. Let's say you give some quadratic curve to something. You want to find out what are each of the parameters towards that curve. You know, it's x squared plus x plus a constant. What are each of those coefficients? You prefer an algorithm to go minimize your chi-squared or other minimization technique to find out what those coefficients are. That is machine learning. You have other things that will do fancier stuff, crazier stuff. You have neural networks. It's all just built around this. You have some algorithm that's going to do, generally speaking, a minimization technique that tells you some parameters to go use. And the model is just going to do that. So think of every time you're just doing best fit curves to something. And when I think of data science, I like to think also the track of what questions are you going to ask as you're doing your work. And these really align a lot with what you'll do in physics. You'll be like, man, I do this all the time. What a coincidence. It's pretty similar. So I think of like data science questions you're gonna ask is if you're wanting to solve a problem, what data do you need to be able to do that? If you're wanting to be on TikTok and find out what the best things to give, what content to give to everyone, what data do you want to have? You want to know what people are seeing. You want to know what the person you're trying to give content to is. Those are the things you want to be asking and figuring out. You also look at, do you have access to the truth data for this prediction? If you're working at Facebook, you're trying to figure out, okay, how do I take this image and identify who's in that image? How do you know what's actually there? You could just make a model that does something, but it could just be wrong. But Facebook has, what makes them really good at doing this is you have a bunch of people who are labeling your data. You click and say, this photo has me in this picture. Every time you want to train your algorithm, if you think those people are correct about picking themselves on their photos, you can do a great job. You have other photos, people just like randomly tag their friends in it. That's going to be bad data for you to use. You should be aware of that. That's what you need to be thinking about as a data scientist. Additionally, when you get new data, say you are working in used cars, you now get some new data from a customer that says, hey, we now have information about those cars that tells you, are these cars scratched or damaged in some way? Do you now have the history of this car? You'd ask, okay, something interesting and notable in this data. Is there some new signal that I could use to make some prediction out of it? Again, signal-based, it's very physics related to things you look for. You want to find something, do I have something that tells me about that in this data, which could be very large dimensions. And then lastly, I think is a really meaningful question in data science is, how would you validate a model? Anyone can make a model. You can just roll up, import scikit-learn, do model. Any blog will tell you how to do this. It's very easy. But what's really tough to do and takes a lot of thinking is, how do you know your model is actually good? How do you know it actually solves the use cases you want it to? How do you know it does the right thing? And what are the edge cases that are going to make things weird? Again, very similar to physics. You think about, you have some equation, you have some theory you're looking at, you look at, okay, what are the edge cases? What happens if we take things to infinity? What if we take things to zero? The same kind of thought process here, just thinking about more generally, more abstractly, how would things look if you're making predictions on cars? What happens if you get a weird car you've never seen before? What happens if you are pricing too high or too low? You have to think about those kind of things as you're a data scientist. Next, we'll move on a little more to talk about myself, what I'm doing in the used car industry. So I'm going to summarize CarMax's core business into 3 bullet points. So all we do is we buy cars, we fix them up, and we sell those cars back to customers, ideally for a profit. That is all we do. We're just flipping cars. What makes me do interesting work as a data scientist for that is, one, CarMax has the most data available. No one else has more data on more cars than we do. And we can use data science on that. We can make products that do each of those components better. Tell us what cars should we buy? How much does it cost to fix up each car? And then how do you want to price cars to your customers? Think of that as just a simple equation. You want to put some price out for your customers. It's going to sell that car at the right speed. You want to figure out how much profit you want to make on that car when you're selling it. You want to figure out how much it's going to cost you to fix up a car. And that tells you exactly how much you should offer that car out for each person. However, if you're off by $1,000, $2,000, $2,000 on how much it costs to fix that car, you've now lost money. That's not great. So you want to do a great job of knowing how much it costs to fix each car. So for example, you can make models that say, based on the data we have on this car, how much is it going to cost us to fix the scratch on the car? Do we need to replace these panels on the car? Is something wrong with the windshield? Is something wrong with the seats? How much does that cost? What do the tires look like? And so you make a model, you get some data about that, and you think about, okay, what data do you need to be able to determine these things, right? Is it enough to just get text input that just says, hey, there's a scratch here, it's this long, run that into a model? Or do you need to have images? There's something that maybe a person can only do. So you need to go see like under the car to see something. Does that tell us more? What data can we get? How long does it take for them to do that? Can we do something that takes less time and gets us still mostly as accurate? That can be worthwhile to go do. Think about for pricing cars to our customers. How do you know you get the right price for a car? It's not obvious, right? You think that if you price a car too high, it's not going to sell. If you price a car too low, it's going to sell quickly. But every car in a used car industry is unique. You're not selling cars with 0 miles. You're selling different cars of different years, different mileages, in different locations. And you're trying to guess from there what you think that car would sell somewhere else with different mileage. And so you figure out you only have one data point per car. You're not going to sell a car multiple times. You can't, give it 2 different numbers for its price. You only have 1 number for its price you're going to send out. So you only get that 1 data point to figure out, okay, in an ensemble average, how do I know that I'm selling cars at the right speed that we want to sell cars at? Then from there, take out to what cars should we end up buying? How do you know a car is going to be a good buy? How do you know you're not going to have like a car that has some frame damage on it? You don't want to sell that car. You don't want to make a mistake there. It's going to be super expensive. If you can know how much it'll cost to fix this car, you want to know where that car is. Is that car going to be close to our stores? Is it going to be close to where we need it? If it has 4-wheel drive versus 2-wheel drive, that's going to work different things to customers who live in a snow place, person who lives in Florida. You have cases where Florida ends up flooding recently. Do you want to change anything for what cars you're buying around to get more cars to Florida so you can sell to more customers? You need to go get new cars. All those things are going to be done through data science at CarMax. Any more questions here before I move on to this is very big picture here, but I want you all to be aware of these are the problems we're really focused on solving. There's other problems we do with data and data science at CarMax, but this is the big problem, the core problem for the company. Cool. Move on a little bit, talk a bit about what data science work really is. I want y'all to take all of this with many grains of salt. Data scientists throughout the industry will work differently. Different companies will have different roles. Data science is a very vague description. Some people only do like modeling and they hand off their models to people to fully implement it. My role is a little bit more start to finish. I'm responsible for like initial work on models and also most of the work to deploying them. I don't run our like prod systems that run all the time. That's other people do that. That's too much work. It's very stressful. But my job is to say, here is this model. I want it to implement like this. It should fit in your system this way. So all that to say, kind of give a rough description of what my work ends up being as a percent. It's not like you can't break it off into a day because some days we'll do all of one or all of the other or a mix and match, but kind of like averaging out my career over the last few years, what have things look like for me? So the first bucket here, which will be the top right part of the pie chart, is going to be training models and data exploration. This is probably what you would generally think of the most when you think of data science. It's like the least amount of time that I spend working. And it's also the easiest part of my job is training a model and looking at data. It's just easy, is all I can say. Like if you want to make a model run, all you do is Google, how do you make a model work? You find the code, you ask ChatGPT how to write the code for you. The code will show up. Training is very easy. It runs very quickly. It's easy once you're trained to know how to know which model is the right one to use. It's just the most straightforward. It sounds pretentious to say it's the easiest part of your job, but if y'all think about doing your own analysis work here, like, do y'all really spend that much time trying to make the graph, or do you spend more of your time working with the rest of the data to get things to work for it? That's the hard part. So moving towards the harder parts that are more complicated and take a lot more thought and energy, the next bucket I want to talk about, going clockwise along the pie chart, is validation and test design. So once you make a model, the trick that's hard to go think about is, does the model work as you intend? If I'm making a model that is pricing out what we think it'll cost to fix up the car, I need to go see, is it getting all of the cars correctly here? What happens when we're off by a lot of dollars? Is that going to be a car that we can still sell to a customer? Are we going to start buying new cars we wouldn't buy otherwise because we think the cost is lower than it actually is? You can't test that because you don't have the data to know cars you don't buy on. You need to go find a way to be able to go test and see, how could we see what happens here? And then you look to see, are we going to have our customers go online to tell us different things about the car? Do we need to get new data from them? Is that going to change how that looks online on the website? Are we going to change what our associates do at the store to go look at more things on the car? Or we have them look at fewer things on the car? Is that going to change how their engagement is at work? Do they like doing this thing? Do they hate doing this thing? That's all important for us to go think about and talk to. We also need to know and see, can we test this fully when we're doing our new models? Is it something we can do an A/B test of? Can we send, if we're pricing out cars, again, some example here of looking at how much it costs to fix up a car, you could run one model on one car, you run another model on a different car, make that random, you'll test and see, okay, with this version, we use A, it costs us this much money. With B, it costs us this much money. Compare those two. If we look going forward, you could say we would make $10 million using this new product. We should go use that new product. That's like a big thing what we do to figure out, is it good for us to go do this? How much money are we making? We have to be fully quantified with that, with the organization to say, we should go make this change. We should change how the business operates because of it. Next up, this is the biggest chunk I want to talk about, is data wrangling. This is something you'll have experience of in physics. It only gets worse outside of physics, unfortunately. Data is just so nice and clean in physics. You might not think so. You might be like, Chris, you're full of like, no, it really is so much better here. You're going to get data that's like, here's the voltage over time. That's always going to be a number. Like in real outside physics data, when you're relying on people entering in data for you, when you have 20-year-old databases, like databases like probably roughly as old as y'all are, like it's not going to be great. There's going to be things that are weird. There's going to be things that have changed. Data contracts will have changed. Like the data you think should only look like this won't always look like that. You have to go figure out does my model, does my data work well enough for me to use? Am I training on bad data? How can I take what is going to be text data and fit that to be the way I want it to? If you're getting data from a vendor or a customer to run your model, this is happening to me this week. They might change that without telling you. That's very painful, that you have a model that runs on something that you've told them not to change on you, that they just go ahead and change on you. So it's a lot of work here. This is the most work that I spend my time doing, is how do I set up the data to work? How do I set up the data architecture to work? How do I make sure that my data is processed before and afterwards correctly? I have all of the things that work around the model itself. So think if you get data from somewhere, some magic has to happen to it. Then you run your model, you do some more magic for it to go out, and then it goes and makes a decision. That extra stuff is by far the most complicated and the most like detail oriented. But also gets to be fun examples when you want to talk to management about little things. You'll like look up random cars, like, man, my model didn't work on this car because someone poured paint on the backseat of it and we didn't have anything to train that on. Like, sorry we missed it, but it's one car and like that's what we're gonna miss. Like, that's a good thing to give to management and talk about. And it's not something you're able to do with your AI. Lastly, the last piece of what I would talk about that I do, it's a really important part of what I do, is data monitoring. To know you have a model that's running, it's out in the world, in the wild. Models I have running right now are spending like billions of dollars year over year at the company. You got to make sure that like it's not messing up. Like it may have worked really great when you're doing your test. Can you be sure that in the future, when the used car market goes crazy because of COVID, that it keeps working the right way? It's really important to be able to have things that can monitor that in real time, can be aware of when things are changing and make sure that things don't fail silently. That's a big thing you want to avoid having happen when you have a model. Say it takes a bunch of inputs and one input could be null. If you end up having more nulls than you had before, you may not detect it and it may be worsening the quality of your model. You have to be aware of that, be able to see that happening and make changes in real time. Last section you want to talk about here for talking about data science. Question is like, are we bad people for what we do sometimes? Quickly, are we taking jobs from people doing data science? My answer is kind of. One of the things we do with our role is increase automation. Like by definition, one of the ways you provide value, you take a job that someone was doing, these take them like, a minute to do on every single car. People look at 100,000 cars, you do something that makes that take half the time, you need half the number of people to do that. Like that's a thing we need to be careful about as we're making models. Are we taking things away from people? And where I think to add some like more nuance to this, I think naively you can think like, yeah, if you're doing work people were doing, you make them do less work, you can either take jobs away or just make hiring not happen for that role. But you should really think about, to be great in your modeling, how do you actually use human elements for decision making? So it's not just that you can have your computer do all the decisions. You can make a model that says, every time we see a car, it should cost this much to recondition it, or every time we want to buy a car, should that decision be entirely made by a computer? You could have, other than a spectrum, only people do this. Only a person would go look at the car. They've experienced looking at a bunch of cars. They could say they'll cost us this much dollars to go do. We should or should not buy this car. That would be like the two ends of the spectrum of what you could do. AI only or human only. Somewhat, blithely, you can have anything in the middle of that. You can hand off decision making to a computer or to a person. And it's really important, I think, to look at modeling as a way to find ways to blend that together smartly. You could find out what class of problems do people do better or enjoy doing more, and then what class of problems do computers do better, and maybe things that people hate doing. People won't mind doing less work if you hate doing this task. If you hate doing paperwork, you hate looking at things like that, make a computer do it. You might take their job away a little bit, they might have other things to go do, but they're gonna have a lot more engagement, be much more bought into the idea of not doing that work if you take away the crappy stuff. And so the models I was doing that take away some of the work that people are doing to say, hey, you're making a decision. You don't need to make this decision on every single car. You should spend your time spending more time making decisions on the harder cars to go do. we make more money off of those cars. You should focus more of your work on that. Let's do the easy stuff for you. You can spend half the time you would do otherwise. You can either spend more of that time working there or working other things in the store. And that really helped us out a lot in the pandemic. A lot of staffing issues, people are calling out sick. If you have less work to go do, you're able to spend more of that time more effectively at the store. So that's my nuanced side of things for taking jobs away from people. It is something I want y'all to be aware and thinking of. If you do want to become a data scientist, some of your roles may involve being highly focused on automation. We have a lot of chats at work about this. We're putting out models like, what are we doing to associates? Are we taking their jobs away? Or are we just preventing hiring happening here? We'll let attrition take up the rest of it, or we still want to get that value for the company. And you want to make sure you're not having people do really crappy jobs out in the sun, out in the cold. They're going to be happier doing other work for us. So to end up here talking about data science, towards the skill set, I think that are the biggest cross skills you'd have from physics to data science. I like to think of it a little bit maybe differently than you'd get from other people, as to what like the physics PhD will build for you. Because I would argue that the ability of someone with a PhD to generate and read a graph is your biggest competitive advantage. So now a lot more places are universities are having like master's programs for data science. You can go get a bachelor's of data science, you get a master's of data science. But my experience of what they would not have versus a PhD candidate or someone with a degree to go do this job is to really look at a graph. Like, this is what y'all do every day. You know, grad students take coffee, they create graphs, and you look at the graph and you figure out, okay, this thing here should go like this. Why is it trending like this when I think it should trend like that? Your job is to go figure out what is happening or what's the cause and effect of this. If this is happening here, does that mean that something is wrong in the data? Does that mean you should do some better analysis to go do better data wrangling on it, to do more post or pre-processing on this data? And you can go look at, okay, if I want to do something slightly differently, how should I expect that to look? That is a skill that is really hard to develop outside of the PhD experience. Because this is what you do. You spend time in journal clubs, looking at things, looking at data, looking at graphs, figuring out what is this trying to show me. That is hard to train outside of that. Even if you don't have like coding experience, this is a big thing for data science, what you need to do to be really good at it. Additionally, this is kind of a little more basic, but having just math and stats knowledge, that's kind of very, if you haven't like formally taken a statistics class, that's just part of how you think and speak in physics. Understanding error bars is a big thing that talk about hey, what are your errors on these things? That's a very common language in physics. It's not as common outside of that. That's a big thing you bring to the table. Additionally, what's really difficult to do and takes a lot of work is how you translate language from people who are much more business focused to what is much more of an analytics focus. So taking what your goals are. Here for us at CarMax, we want to buy, more cars and buy more profitable cars. How do you transfer that goal to the correct analytics to look at what math are you trying to do? How are you trying to optimize that? What should be monitoring? All of that needs some language transfer. It's all just like word problems, effectively. How do you make that into an equation? How do you think about that on the code and data side versus how do you want to describe that out to other folks in the organization? Additionally, have along with that is just presenting ideas. Whiteboarding is common. Like my office, when we rarely go in once a week, is full of whiteboards that we wheel around and we talk to that are using whiteboards. Hey, I'm trying to think of this thing. What are the steps I'm trying to do? You're whiteboarding the whole time. You are during journal club, having ideas. You go straight to a whiteboard to talk. That's a really important skill to have that you get from a PhD. Additionally, doing elevator pitches and presentation is a big thing to do and practice in a PhD program. When I put plugs for, I think they just had, was it today, yesterday, the 5-minute thesis competition? 3-minute thesis, yeah.
I think you know about us constantly.
I bet.
3 months.
Yeah.
Yeah.
Did any of y'all do it? Have any of y'all done it? Okay. Do it. I recommend doing it. You're practicing giving a short version of what you do. You should also have a way to talk about the long version of what you do in a formal presentation. You're presenting out like, hey, my model is doing this thing. It's going to change the business in a fundamental way. You want to have a way to present that nicely and cleanly and understandably out to the rest of the organization who may not have a data science background to say, hey, your job is going to change significantly. If we're wrong, we could lose a crap ton of money. We don't think we're wrong because of these reasons. We think we'll instead make tens of millions of dollars a year more because of it. You want to make sure you have that presented well. You have that experience from your PhD, you go to conferences, you have talks all the time in different environments. Additionally, if you're talking to your manager, it's a very different environment, but very similar to having your one-on-ones with your advisor. You want to talk to like, what are you working on? What are you trying to do? What are you trying to do to develop yourself as a scientist? You're going to have the same conversations your managers at work. What are you trying to do? How do you prioritize your work? How do you get things done? And then additionally, how are you trying to develop yourself in your career? Same kind of things are happening. You have that same experience from physics. However, there's definitely things that I'll talk more myself, what I had to learn, but things that are not fully handled by a physics PhD. If you want to change fields, you have to learn new skills. It's just a fact of life. So a big skill I had to learn and think about was identifying good data science products. So when I did the Insight Data Science program, I'll talk more about that later, but I did like a boot camp going from my physics PhD to go into industry. This is probably the biggest thing that they had us work on and spend the most time doing was you can just make a model on anything. Like it's really easy. You could go look up on like Kaggle.com, I think has a bunch of like mini data science products. Like here's a data set, do a thing, get the most accurate thing you can get out of it and call it a day. That's not really at all what you do as a data scientist. You want to figure out what is something here that could really be a product. What can we actually sell to customers? What can we do to change the organization? What can we do to make decision-making with our data that is worth the time and effort that we would spend on it? Do we have the data we need? How do we find the data we need? That is a very data science specific skill that you don't necessarily fully have from your PhD. You need to go learn that, and it takes practice. Additionally, writing good code was a big thing I had to learn. My time in my PhD was probably 50, I don't fully define it, like roughly 50-50 of hardware work and analysis work, where I'd be either with a wrench and a hard hat and like steel toe boots underground, or I'd be on a computer trying to type up some simulation or some analysis. The code I wrote in grad school, not good. I'm gonna flat out say that. It got things done, it worked, it was just fine, but it wouldn't go to a production system to like, these are things that need to run full time, need to work in weird edge cases. Core is code. People would push changes to it and it would just break all the time. There's a reason it took so long to get the analysis code out. Something would change something, the whole thing would break if it spent time to fix it. So like learning how to write code correctly, how to write unit tests, how to do code reviews, took me a lot of work. I spent a lot of time learning as I was trying to get ready to do my data science work. When I got the job, even after I got the job, I spent a lot of time finding people who were smarter than I was, who had formal background and training to be like, hey, I want to like sit down with you for, I scheduled an hour and it'd be like a 3-hour conversation a few times, just like walking me through the philosophy of how I should think about writing code. How do I write good unit tests that can be used to go to production? How can I go through a code review here and look smart? And people was like nod along, like, yeah, okay, Chris is just doing his code, it's going to work, it'll be fine. That took a lot of work to think about. And additionally, part of that good code, I'll include also thinking about data integrity, how to build a system that can work to collect data from things that can change an organization all the time. So during COVID, I had switched to train teams a little bit to help out with things going crazy in the used car market. Things were blowing up at our stores in a bad way. And we were like working week over week to like do something totally new, a wholly new play for us to go run. People would go and purchase and rent this physical spaces to put cars at like random like airport lots, at auction lots, just like random places around. And like they called me up and said, hey, can we build like a data system to store this information? I was like, cool, what's it gonna look like? And I said, I don't know. And I was like, need to run that next Monday for the first time. And like had to run and go work. I had to go build data systems to like, how do I get data? What do I need to know about each site? How should that connect to this table and to that table in the right way? Can we pull it into our system in a process to go run? And that was a lot of work to go figure out. That was not really a PhD thing that I had learned. Next up, I'll talk about is working inside of a corporate organization is very different than working inside of an academic organization. I mentioned this a few times already. Being a grad student, you are like a jack of all trades. Like I was spending time underground in Italy, like literally with a wrench or like fiddling with strings to go make something work. I also spent time writing code. I was just doing so much. I was working on my own logistics for all of my travel and things. I was like doing things to get our car inspected in Germany. Like it was a lot of work. In a corporate organization, you have so much more like machinery around you to get stuff done that you don't have to do everything. I'd like to know more things than I work on, but I don't have to do everything. I'm not responsible for running all of our code to make sure that our systems stay up. We have people who are dedicated for systems or data engineers whose job it is to make sure we have 100% uptime and everything. That's not my job. If I were in grad school, that would be my job. And so it's nice in some ways to have these kind of limits around what you do, but it's very different than just like, as soon as you get done, I'm gonna go do it. You have to go think about how do I go talk to people to get things done. It's not just you, it's other teams. How do you get them on board to what you need to do? How do you establish the right communication with them to say, hey, I need this from you. I need this data contract. I'm gonna give you this data for you to go get stuff done. It's gonna look like this. I need this from you, it'll look like this. And then lastly, just like working at a faster timeline, like I got so much more done in like 1 year of being working in the industry and corporate world than I did in probably like 3 years or more in grad school. It's just a faster timeline. You can give out what's like good enough to get done. You can prioritize work a little differently. It's much more organized, like get your priorities done, get that to happen, and then move along. Very different than academia. So next one, transition to talk a little about my pathway data science. That clock is off, right? That's total. Cool. Perfect. I'm not so bad on time.
1:40.
Perfect. Okay, thank you. So thinking about the PhD timeline, I'm going to give for y'all what I put for my mental framework here, how I kind of divvied up my time as a PhD student into 3 segments. They don't necessarily like all have to fit into like this set, this set, this set. They were all kind of jumbled around a little bit. It was roughly these 3 main buckets. So I think I want to categorize my first few years in grad school was really focused around learning and listening. So I could think about like what was out there for a career, what things existed. Like again, like I mentioned earlier, like data science didn't really exist when I started grad school. I had to go to talks and things to see like this thing exists. Find out what things that I learned about what might seem cool and interesting to me. Should I go learn more about them? Figure out what other people are doing. That was all like just learning, listening, like kind of hearing out what's out there, go to things, experience it. The next phase I call doing and networking, kind of the middle part of my PhD. Again, the dates are very flexible. Which is really focused on kind of putting your head down, getting involved in interest, build experience in those interests. If I like doing something, I think it's interesting, I should go find out, do I actually like it when I'm actually doing it? Is it really what I think it is when I'm doing it? And additionally, as I'm doing that, I'm building out connections with more people. I'm going to highlight here older graduate students to be mentors and postdocs in particular, people that will be finishing before you. You can see where they end up going. And then lastly, the last bucket here was more in the deciding phase, year 5+, how long it takes to actually defend. What I'd put here is really just kind of focusing on imagining yourself being in these roles. Are you happy if you think of yourself as a data scientist? Are you happy if you think of yourself as a postdoc or a professor? Would you rather do teaching or whatever kind of role you want to be? Put yourself in those shoes. And then go leverage out those connections you have, what you've made before, people in your cohort, older grad students, postdocs, and others, to find out what can exist and what opportunities you can have. So a little bit for my own path, really important for me to go attend talks. So good job, y'all are doing the right thing there. Sign up for email lists is a big thing to do. You won't know what's out there until you're on an email list for it. I also recommend going out to find career strategy events. Those are very helpful for me. Actually end up being more helpful in like year 4, 5, and 6 for that. Just to know like, how do you negotiate? How do you do things like that? Very important then. My middle part was really getting involved in what were my interest, things I learned about in my first few years, doing a lot with pathways to science. I was very interested in doing teaching and education. So I was in the CTL, now it's the Poorview Center, as a fellow and a tutor. And I worked a bunch with older students and postdocs in the lab and throughout, to know what they're doing, what's happening with them, where are they going, are they finishing? And then lastly, in my final years, I did some more like little mini projects to learn like what data science things are fun. I did informational interviews with postdocs, talking to professors and saying, hey, if I were in your lab, what kind of things would I be doing? Additionally for me, I did like mental rotations into careers. So I think of like, okay, let me put myself in the shoes of Chris is going to go be a postdoc. Let me do that for 3 months. Let me focus on, I'm going to make that my career choice. I'll talk to people and say, yeah, I'm thinking about doing a couple of options. And I'll just say, not like intending to lie, but kind of just putting it out there as I'm thinking more about doing a postdoc for my postgraduate path. And as you say that, something like very like weirdly human, you might be like, oh, that's terrible. And you're like, wow, I don't like saying that. Do I not like doing this as a career? Use that as a way to kind of think about what you're doing, what you're deciding on. And I'll talk about my post-academic path here. I was pretty burned out on research by the end of my PhD. I was very tired. I was doing a lot of trips to Italy. It's very exhausting. Dissertation writing is a slog. It just is. As I was doing my career rotations, I was sending out applications to data science programs, namely Insight is one of them. Insight no longer exists, unfortunately. Other one is Data Incubator, which still exists. I enjoyed doing those side projects as I was doing the application process, which is really important for like self-esteem if you enjoy doing the thing. I ended up getting accepted at Insight at first. I had my first timeline to defend at their Seattle location. I wanted their remote program, just me personally was better for my situation then. I was also too scared to move for a job at the time. Like I didn't have a job. I would move to Seattle, spend money to move to Seattle, and then be there without like a particular career prospect, like fully in stone, which is very scary. And also I was writing my dissertation, it was just taking a lot longer. So I just like said, I'm going to apply next time, and did that, got in, and then did the program. And so advice here is like, if you don't get accepted, I didn't get accepted the way I wanted to at first, like feel free to like postpone. A nice thing for a PhD is you don't have like a hard deadline, which is also a terrible thing. But you don't have a hard deadline. You can be flexible there to make things work for you. That's best for you. How did I know about data science? It was through mentoring. Again, I mentioned before, like I followed folks who were doing trailblazing. My first postdoc I had when I first started on Quora, her name was King Yin. She did a faculty job search. Her experience with that wasn't terribly positive. Ended up switching out to go do Insight. She was the first one that I knew to do this program. She did the program in New York City. I had a friend living in New York City, went to visit him. And I was like, well, King Yin's there. Let me go visit her while I'm in the city. Again, this is part of the networking side of things. Just like visit your friends and coworkers. So she was working at Insight. I went to go visit her at her office there. Did a happy hour. Got to hang out with her, talk to folks in the program, be like, oh, this is kind of a thing. This is what this would look like here. I had other friends of mine afterwards also do a similar path, go through similar programs. Some folks went straight to data science, just applied during their PhD, got in, and then went in just to a job. Other folks used a boot camp. I quickly went for a boot camp. And I noticed pretty much across the board, they all seemed happy, which was an important thing. I remember looking at grad schools, and I was first looking at grad schools to go to and being like, this grad school here, like they don't look happy at all. But this grad school here, yeah, they seem reasonably happy. I want to be happy, like, let me go there. So it was a kind of a helpful thing for me to find folks that seemed happy in their roles. And then about why I went to go to a data science bootcamp in particular. I'll say I had relatively low self-confidence for myself in being a data scientist. I didn't feel very good at coding. I had some people about positive mentoring. People also said like, Chris, your coding isn't that great. Like somewhat spitefully to them, I'm now, coding full time. but I just didn't feel like great. I wanted some experience to do something that would help me with my coding. I thought making data science models was hard at the time. I turned out very wrong in that aspect. Like, again, you Google it and you can find out how to make a model run very easily. It takes you 10 minutes. I also perceived doing a data science bootcamp as having lower risk. The programs I was applying to and going to at the time had no cost. And I could also do them while I was finishing my PhD. So I could still like have this safe fallback for me, which I thought was very important when I was trying to like go do a new thing I hadn't done before. And I also really look forward to having a community to work with. It's a lot easier, as you all will know from grad school, and you have a cohort people to be with in grad school. They can be your friends, they can be people to work with and learn from and learn with, and just are similar to you. It makes learning and doing new things much easier. I felt that were good reasons for me to go try and do a boot camp. And I really had a great time with my fellows. And then talking a bit about motivations for my decision. For me, I was really focusing between 3 career paths when finishing my degree: teaching, research, and data science. So I had to look a little bit about thinking critically with a lot of self-reflection, like where I wanted to be with a career, what I wanted to have as my success metric for a career. What would I think, when I'm 50, would I think I had a successful career if I did X, Y, or Z? Could I make those happen in each of those careers? If I became a professor, would that be a success metric? If I became a data scientist, did modeling, would that be great? If I did teaching, what would that look like for success? It's really important to figure out what those metrics are. Think about as well for timing. If you're doing the research path, it's really important to go straight from your PhD program to a postdoc to a professorship. You have to like publish. Like, you can't really take time off to do a different career and then come back to it. Some people can. I think Sarah Demers here as professor took some time off and is a very great professor. So like, not a hard rule, but it is a little more difficult to do it that way. And I also want to think about for myself, how did I feel about work-life balance? My experience in grad school was pretty negative work-life balance with how much traveling I was doing, and just generally grad school is a lot of work. I want to think like, is that something I want to keep doing? Do I want to do more of it? Would I get more out of doing it if I did different things? I want to figure out what the right level was for me. At the time, I also had a 2-body problem. So I think like, well, how do I support a family? How would I have a career that would work with my partner's career? Some folks have, their partner will move for you. Some folks, you want to move for your partner. That's very important for like where you're going to live. Do you have determination for where you live? I think in academia, that's not really so much of a thing. The job appears, you're going to move where the job is, and that's just a fact of life. In data science and industry, you get a little more control for, I want to live in this city, I can go find jobs there that exist. Now that remote is much more of a thing, you could live anywhere with internet connection and you'd be fine. And then lastly, another motivation factor for me was if I wanted to be a professor, I saw that there was, a lack of growth in open jobs in academia. They had a lot of people applying for very few jobs. So I think like, what was my chance of being a postdoc and then successfully getting a research professorship? All for me were motivating factors. And then I kind of add here, things I think that are great about data science. I'm going to go through kind of each of these buckets here. One thing I really like is the high impact from your work. There's a lot of multiplication factors on the things you can do to go out to nationwide or international wide impact. I made models that changed how we did our entire business around the country. It changed how we spent billions of dollars. It changed how we made tens of millions of dollars more in profit for the company. That's pretty huge. It's really exciting to see that. I drive along the road and I see CarMax trucks moving different ways because I was telling them to move different ways. That was really cool. Additionally, another great thing, I'm going to say it here, is it's a high-paying job. It's a job that's in demand. Tech is somewhat not doing so great right now, but still, like, data science is still an in-demand role. You will get much higher pay in data science than you would in academia, for sure. Also, it's remote friendly, kind of post-COVID. All the barriers, there was kind of a few people I knew would work remote, but it was definitely like much more the exception than the rule. Now, most places can prove that people can work remotely. So if you want to work wherever, you can do that. I also like data science. A lot of folks that I work with are kind of also post-academic like I am. who have this research focus and they're very engaged coworkers. Conversations really haven't changed too much at lunch, going from my research experience to industry, which for me was a big fear when I was leaving. I think it was like, man, my coworkers are fantastic in grad school. I like working with grad students. Is it going to be the same for me outside of it? For me, it's been very positive. Another thing I like about data science, kind of weird thing to say, but it's easy to quit. If you aren't liking what you're doing, if you're not happy with where you are, you can easily find another job elsewhere. You can just, if it's remote friendly, you can just quit and go find your job somewhere else. You got get 2 weeks notice and you can just move on to somewhere else. It's weird to say, I think it's a huge plus for a job. Additionally, kind of the last 2 buckets here, things are open source. You can use things built by other people, which is fantastic. You don't have to write all of your code. Like research is very much like you are building, like you're so cutting edge, bleeding edge, like there's no one else who has done the thing you are doing. In data science, I can load up models that people have built and prepared, make them work for my own use case, find other things people have worked on Stack Overflow, Stack Exchange, make that run for me. It's fantastic. And additionally, I like working with cool technology. Research in a physics PhD is like really cool technology. You still get to work with that in data science. It's fancy stuff. It's really cool, like big computing to run things. You're still working with the most cutting edge technology. You have things like ChatGPT that just came out, like huge things that are like really like on the edge of where tech is moving. So we're running low on time here.
154 if you want
yeah.
to maybe give 5 minutes.
Yep. This is like just a couple of slides here. So this is going to transition to the more like personal, emotional side of making a change. So kind of how about things you are going to feel about changing your career? I think the first thing is you're going to feel anxious at times, maybe a lot of the times. It's just a big bet when you're trying to change your career. You're betting like your future livelihood to have a career. Like, doesn't work out. Are you going to be a hobo? Do you have somewhere to live if you don't, like, can you pay rent if you don't have this work out for your career? When I was switching out of my PhD program, was like, okay, my income from my PhD program ends here. I'm hoping to get a job before here because these are my expenses. I only have so much money. Like, that was a pretty anxiety building thing for me. So you're going to feel that. You'll also feel very excited at the same time. This is something new. You're doing new things all the time. You're gonna do things you haven't done before. That's very exciting. It's very cool. Additionally, you're also gonna feel really smart. So things you're gonna pick up really quickly because you're smart, or things you've done similarly in your PhD program or other things that you've done, like it's gonna come to you like real quick. You're like, I know how to do this, done, it's so easy. However, there's gonna be things that you're gonna have roadblocks. Like you're learning new things, you're going to be feeling dumb. You're going to be like, I'm a failure. Why can't I do this thing? It should be easy, but it's not. And you're going to just like, I can't do this thing. I'm a total failure. You will feel probably all 4 of these things at different times, maybe at the same time. You can feel smart and dumb. And then additionally, some things to feel when you're job searching. This will be true, I think, not just for industry, but in general, job searching as a postdoc or for faculty jobs. You're going to feel super frustrated at times because I think the most stressful part is when you're waiting to hear back from an application or a decision. You have interviewed at a place. They told you, great, thank you. We'll be getting back with you in a couple of days. They don't tell you when. And then you have to wait all of those days. Those days feel so long. It can be like a week. It's going to feel like a month. You want to go through a whole process. It's going to feel like, half a year. It is just the slowest time ever. Very frustrating. You'll also feel failure because you're probably going to get rejected at least once. Sometimes you'll try something, you get rejected, try again, get rejected again. You're going to have to kind of deal with that level of failure. It's going to happen. However, you also feel like you're very hyped up on yourself as you are prepping for an interview. Like, okay, here's my personal story. Here's the things I'm doing. Here's why I'd be a good fit for your company as a data scientist. Here's why I'd be a good researcher or whatever. You're gonna be like, I'm so cool. I'm the best. I'm the greatest. And then you're gonna feel really good. And so you're gonna feel that at the same time, you may feel like a failure. It's a weird combination of feelings to have all at once. So give you all some healthy coping mechanisms. Here's a way to end the talk. I think you should make sure to feel that it's okay to go take breaks. It's okay to go outside and touch grass. You should feel that things are new, but don't like get overly excited and burn out because you want to keep doing things all the time. When you hit a roadblock, when you feel tired, just like take a break, go rest, go outside, do something else. Additionally, probably the biggest thing here I want to talk about is asking for help is very important. I think PhD programs in like physics in particular have like the big like genius complex that like you should be the one to figure out all these things by yourself. If you're relying on others, you're just not as smart. That is not true. And so it's really important to find people through your networking or whatever community you have that are also learning with you or have already learned these things and rely on them. Set a time limit is my like actual like most mechanical like thing to do as a recommendation. Like say, I'm going to try and learn something, but don't spend more than half an hour or an hour on something. Like time yourself. If it's more than an hour and you've been struggling on something and just like hitting a wall, reach out. That is the way to go forward. You will learn much more from reaching out than you would from struggling on your own. By far, there's things I could not have done had I not reached out to people. Additionally here, about the feelings I was talking about before, be patient with yourself when you do feel that way, when you feel down, when you feel anxious. Those are like normal responses to go have for yourself that you should feel that way. It is okay to feel that way because you're doing something weird or new. But I want y'all not to feel bad that you feel bad. Like don't like too much metacognition of this stuff. Like it's okay to feel bad. Don't let that kind of spiral down for feeling bad about feeling bad. Like feel that, accept it, and move on. And then lastly, find something productive to do while you're waiting on job replies. For me, I had a dissertation to write and I was waiting for my jobs to get back to me. And I wrote my dissertation, like the last parts of it then. That was something really great for me to like be productive and also get my mind off of just like, are you gonna get back to me? Am I terrible? Am I great? Like, it's just a whole like place to be in your head that you don't want to be in. So yeah, I know we're right on time here. So there's a few minutes left here. I can spend a little time, I think, afterwards, hopefully, if you all have anything you want to talk about to discuss or ask questions. So.
Thank you for a great talk. I think we'll take questions from the Zoom people first, and then we can open it up to the whole room. So does anyone on Zoom have any questions? Okay, cool. Any questions from the room?
Yeah, I have a question. So you said that business knows lots of things like how to read a graph and explain it and how to, some of them how to do unit tests, but like how do you tell employers this? Because do they know that a physics PhD automatically? I mean, some physics PhDs maybe don't.
I'm being somewhat general there, yeah.
So how do you convey this? Because you don't presumably have a record in a language they understand.
Correct. Spending time to craft your story to a job interview takes a lot of work. Here I'm describing more like to y'all to hype yourselves up more about your skills, to talk to an employer about what you can do. Your job at a company, or my job at my company is not just being a data scientist. I'm there to solve their hard problems.
Sure.
And figure out what do we need to do to be able to move forward in ways that other people can't do. My experience, my PhD, I've solved plenty of hard problems there. And that's what you should talk about to like, here's the things I'm doing. Here's like the STAR method is like the big thing of like, here's the issue. Here's how we identified it. Here's what we did as actions to go do it. Here's the results that happened. Do that to describe things you do in your PhD and you're naturally going to get to that level.
But so your answer is basically show up in a room and convince them. Rather than like
Yes.
like was this part of the reason you did this bootcamp thing, but then you have something on paper that's maybe a thing they recognize, and like was this relevant? The
fact of your resume will say like Yale University PhD at this time is going to open up many doors for you already. You can kind of ride off of that coattail in some ways, to be able to like
get in the door.
Yeah, people want to read that. If you want to get like a consulting job, you need to have a PhD generally, and coming from an Ivy League is going to make you look better. That's just a fact of life, even if you're the same person somewhere else. You have an easier time to convince someone that you're smart because of it. They may joke with you when you get to your company about like, man, they let you at Yale? Like, man, like, phew. I'm like, yeah, they all make mistakes. It's fun. It's a fun environment. So I think I wouldn't stress too much about that. Focus more if you're like applying for a job on like, how do you talk about an issue you saw, how you resolved it, what you use analytics to go do that. That can be complicated, and try and find a way to explain that in layman's terms, but like really focus on like business problem, maybe research about the business problem, how you resolved it, what about your analytics skill made that possible, and how you did it right. And that'll convince people in a job that like, yeah, you're smart.
How much did your advisor play a role in you preparing for like interviews or getting a job outside of academia? Like, were they involved a little bit, a lot, not at all?
Raina was, I'm super thankful for Raina for giving me the space to do the data science program, because I was in grad school and I'm like, hey, I'm going to take a break from grad school to do a program. Can you still pay me a little bit? That's a very nice thing to go do, and to have that space and like accepting that like, yeah, a student of mine is going to do this program. Because her experience is more the academia side, I relied more on my network and data science to help me get ready for interviews. When I was doing my like wearing my hat of doing a postdoc, there was relying quite a bit on Raina to be like, can you introduce me to people? Like, where should I go? What should I talk about? How do I ask them like about being a postdoc? They're like, yeah, advice is just like, pick the right mentor, find an array of mentors, find the right mentor for the thing you want to go do.
So when you were a grad student, you spent 50% of your time on hardware and 50% on software. How was the transition to working in software the whole time?
I miss it. It's nice when you can like physically find the thing that's not working and like kick it, or like, I feel like just like twist this one little thing, then it would all work. And you have like some arbitrary code thing that's not working. It is different. It was definitely a thing for me to think about what I wanted for a career, of like, do I want to do just like more or less this one thing, or do I want to keep like a broader set of experiences? It is nice to like have a more diverse set of skills that like involves how a flange works. How do you have a cryostat up and running? Is very different than like, does my code pass all of its unit tests? Yeah, if I could have a perfect job, I would still do physical things. It's very fun. The rare occasion I get to go out to the field to talk to like people who are like on the ground buying cars, be like, hey, I have a model doing this. What do you think about this? That's fun. That's like outside the like, I'm in an office or at home, like coding up things. And it is, I think, a negative for the job to just do the one thing, but I take it in stride for the rest of it.
Another question says, how would you describe your work-life balance now?
Oh, it's fantastic.
Okay.
It went a little bit, so one reason I picked the job I'm at is they do have more focus on healthy work-life balances. There's other data science jobs that don't, to be clear. Like the expectation is working 40 to 45 hours. As a result, my pay is somewhat less than it would be at places that have you work 60 hours, but like I make plenty of money and I don't need that much more money for being unhappy. And that's generally been my general work balance, has been 40 to 45. I have time to do things outside of work. In grad school, I had like energy to do things, but I had neither like time or money to do things outside of work. And I was traveling all the time. I couldn't go do things. Even I did quite a few things at the university. Now I have like money and time. I can like go commit to doing things and like learning new stuff outside of work. That's been fantastic. But there have been times at work where it has gotten worse. The last year I had to convert my role quite a bit to do other things at that company because things were just breaking because of COVID. Like used car market went crazy. Other teams just like fell apart because their systems couldn't handle it and they needed someone smart to go rebuild everything for them. There I was working 60-hour weeks for a while. But I talked with my boss, like part of the conversation when I went to that team was like, hey, you're going to work extra hours. As a result, we're going to try and give you more time off because of that. There was a while I had to work on Sundays. Conversation was, you're going to work Sunday. We're going to do our best to get you off on Friday, or at least a half day on Friday. When that wasn't happening, we moved resources on the team to make my life easier. Like explicitly having the conversation of, you're working too much. We are going to focus our team around getting your work-life balance better. That is never a conversation I had in grad school of like, oh, you're working weekends, great. keep on doing that was like an invitation, or like there comes like, paper news, get ready, or there's a conference coming up. And I'd be like, well, I can't work, I can't be at a meeting like, on Sunday or Saturday because I'm trying to do this outreach event. And I'd be like, I got flack for it. And I'm like, come on. Never happens to me in industry.
Do you have any advice on like trying to suss out what companies will be better for that than others?
Ask them.
Okay.
There's like, ways to ask, like, you go to interview, they ask you, do you have any questions? You say, well, what are your hours like for people in the company? And they'll tell you a number, but it may not be real.
Mhm.
Ask them other questions that might go around that same way. Ask like, what do you do outside of work? When do y'all and work, are you responsible for doing things outside work hours?
Mhm.
If you're responsible for like making sure the system runs, you're going to be on call.
Mhm.
Like they should note that. You can ask them, do they have like work emails on their phone? That's another good thing. Like, I don't have anything work on my phone at all. That was a big change for me from grad school. I always had emails and Slack going. Experiment was overseas, so things were like 24/7 happening. I always had to be aware. I don't have to be aware here. When I'm not on my computer, nothing's happening. So yeah, ask questions, but don't necessarily just ask the like, how many hours do you work?
Yeah.
Ask like, do you all have families? If there's a company that's only men, you can be like, why are y'all only men? Is it because y'all have to work 60 hours and all of you like have a stay-at-home wife? Like, that's a thing. You should be aware of that when you're like asking around. If that'll be a big red flag for multiple reasons. But if they're like, oh yeah, we have people here, they take, paternity leave, maternity leave. We just have someone got back. Oh, they have a little thing during the day, they can go leave and come back. That's a way to figure it out without necessarily asking the how many hours do you work question.
Mhm.
So that was a long answer to your
No,
question.
that was great. That was good. Thanks.
Yeah, that's the one. So you seem to define data science, nobody knows what you mean, you define it quite broadly to include kind of thing, but like, from now that you're inside it, are there now boundaries visible to you? Because, I mean, there's presumably a gradation to people who are actually programmers, but like the people you're saying who are on call to keep the system running, who don't know what it's doing, but it must always work.
Yes.
And also there's a gradation, imagine the other direction, to finance, that some of what you're doing, like
Yes.
modeling how much wheat is going to cost next year, there's lots of people on Wall Street doing that.
Yes.
Like, where do you see these boundaries, and like, did you consider jumping over either of them?
They're very blurry boundaries. I put it into 3 buckets. That's a personal thing. You might think of it a little differently. I think of people who don't have formal coding backgrounds are going to be more of a developer role. They're going to be data scientists generally. People who have real computer science backgrounds generally end up more in data engineering roles, which is much more the system side of things. How do you keep your cloud system running so it can always work for people? How do you make sure that all the data coming into the data science models works correctly? How are you getting the right data from your vendors, your customers, going through the whole pipeline correctly? That is a lot of work. That is really hard to go do. And probably in a lot of places, a higher demand than you would for someone like me. Even both are in high demand, but places like really need to find people who can do that. But they're not such like a hard cutoff. Some places, like if you're in a really big company like Wayfair, Amazon, like Facebook, Apple, all those are huge companies. They will have much more siloed teams of like, this team is like very focused on making sure the data infrastructure works. Smaller companies here, I'm calling CarMax a smaller company. There's room, like I've done work to make sure our data pipelines are up and running. They don't have me do all of it for a good reason, but like I'm responsible for part of it at some times. We have an associate, he's going to be going on paternity leave in a couple of months. He's had a kid and they're timing out when they're doing their leaves. And I'll be taking over his responsibilities for like data engineering side. That's fine. But you also have like the
other direction, like towards finance or modeling or prediction.
I would count that personally more towards the analyst side of things. Because I put a pretty strong line onto, and different definitions, people have different places. I put a strong line onto the decision-making side of things. If you have the AI model make the decision, that to me is data science. You can also reasonably define data science as using machine learning to make a prediction that is used for decision making, that you say, hey, here's this thing, I predicted this thing. You go to a decision maker, like a VP somewhere, to say, hey, I think we should buy this stock. That isn't the machine learning making that decision. If it's machine learning is buying that stock without input from a person, then personally, I would define that as data science versus like you are an analyst, use its fancy tools to make predictions. But again,
Maybe more
that's a
ask
personal.
about, do you think there's a boundary in terms of like how employers see it or how people move between roles? Like, is there a line that somehow you're doing, providing information that business use that's used to making a decision, but like people who provide information that the system uses to buy stocks in finance, like, is this I have a feeling there's some kind of a cultural wall between
Yes.
you know, this side and that side.
This,
you are or not in finance.
the wall,
Is
I would say, is more, do you work in Excel or do you work in Python? That's the big transition phase. Like, it is a huge thing. A lot of people I work with, I've had conversations when I move teams, like, we need to transition this team to use Python and not Excel, because we're running a huge business and needs to work better. It's harder to find people to work who know how to do Python. They're generally much more expensive to hire because they can work at Amazon for 300K a year pretty easily. When analysts generally make 100K a year, maybe 70 to 100K a year. It's a very different cost profile for having an employee. That I think is the bigger line. Do you work on a team that uses Excel to drive reporting, decision making, or do you use something in Python that's much fancier and much better to do that? That I think is a line versus a data science definition change. And you'll generally have titles that will reflect that at a company.
Thanks again.
My pleasure. Do want to also add here as a shameless plug for myself. As an event, I mentioned going to events. Where do I go from Yale is tomorrow. One of the reasons I'm here on campus. I'm going to be a panelist at one of the events in the afternoon. It'll be what Elsie is something to whatever, some complicated name for the hall. I recommend going to some of the things, looking at it, see if anything interests you to go to panels. I'll mostly be reiterating what I said here in that panel, but people who are also physics grads and Wright Lab alums will be panelists. So I recommend going to it if you want to or not. Feel free. So, sorry. Thank you.